Is Mars a distant dream, a shimmering mirage in our collective imagination? Or is it the next great leap for humanity, a future where we walk on red dust and gaze at a pale blue dot in the alien sky? For centuries, Mars has captivated our minds, fueling countless science fiction stories and inspiring generations of scientists and dreamers. Today, the prospect of settling Mars is no longer confined to the realm of fantasy. With advancements in technology and a burgeoning understanding of the red planet, the question is not if we can live on Mars, but when. The allure of Mars is undeniable. Its rusty hues, its towering volcanoes, its ancient riverbeds all whisper tales of a planet that may have once harbored life, or might still hold secrets waiting to be unearthed. The dream of walking on Mars is no longer a childish fantasy. It's a tangible goal, a challenge that humanity is poised to conquer. But the journey to Mars is not a simple one. It demands we confront formidable obstacles and push the boundaries of human ingenuity. Our quest to inhabit Mars is driven by a fundamental human instinct: exploration. Just as our ancestors crossed oceans and continents, driven by an insatiable thirst for discovery, we now set our sights on the cosmos. Mars is not merely a scientific endeavor. It's a testament to the spirit of exploration, a symbol of our relentless pursuit of the unknown. This journey is also a necessity. As we grapple with the consequences of our actions on Earth, Mars represents a potential lifeline, a second home for humanity. Establishing a permanent human presence on Mars is not just about survival, it's about thriving. It's about building a new society, a Martian civilization that learns from the mistakes of the past and strives for a sustainable future. It's about expanding the reach of human consciousness and pushing the boundaries of our understanding of life itself. The Red Planet beckons, not as a refuge, but as an opportunity, a chance to redefine our place in the cosmos and write a new chapter in the human story. The journey to Mars is fraught with challenges, each demanding groundbreaking solutions and technological leaps. The vast distance between Earth and Mars, averaging about 140 million miles, presents the first hurdle. Current spacecraft would take roughly 7 months to traverse this gulf, exposing astronauts to prolonged cosmic radiation and the debilitating effects of microgravity. Overcoming these obstacles requires innovation in propulsion systems, spacecraft design, and radiation shielding. Landing on Mars presents another formidable challenge. The thin Martian atmosphere provides minimal drag, making deceleration a critical task. Safe landing necessitates advanced heat shields, supersonic parachutes, and retro rockets, all working in perfect synchronicity to slow the descent and ensure a gentle touchdown. Once on Martian soil, the real work begins. The Red Planet is a harsh mistress, with an average temperature of -81 degrees Fahrenheit, a thin atmosphere composed primarily of carbon dioxide, and constant bombardment from harmful radiation. Sustaining human life in this unforgiving environment requires ingenious solutions. We need to develop self-sufficient habitats, capable of providing breathable air, regulating temperature, and shielding inhabitants from the elements. These habitats must be robust, adaptable, and capable of withstanding the rigors of the Martian environment, from dust storms to meteoroid impacts. And they must be constructed using materials either transported from Earth or, ideally, sourced from the Martian soil itself. Beyond the immediate challenges of survival, establishing a permanent human presence on Mars requires creating a closed-loop ecosystem. We need to find ways to grow food, generate energy, recycle waste, and produce essential resources, all within the confines of a limited and unforgiving environment. And we need to do it sustainably, ensuring the long-term viability of the Martian colony while minimizing our impact on the planet's fragile ecosystem. Building on Mars presents a unique set of architectural challenges. The thin atmosphere, extreme temperatures, and constant threat of radiation necessitate structures that are both robust and adaptable. While early Martian habitats will likely be prefabricated modules transported from Earth, the long-term vision involves utilizing Martian resources for construction. Martian soil, rich in iron oxide, can be processed into bricks or used as a component in concrete-like materials. One promising approach to Martian architecture involves inflatable habitats. These structures can be compactly transported and then inflated upon arrival, providing ample living space with minimal material requirements. These habitats can be buried beneath the Martian surface, offering protection from radiation and temperature fluctuations. Additionally, 3D printing technology offers exciting possibilities for constructing Martian habitats. Utilizing Martian regolith as a building material, 3D printers could create customized structures from living quarters to laboratories, directly on the Martian surface. The design of Martian habitats must prioritize functionality and sustainability. Energy efficiency is paramount, with solar panels and potentially geothermal energy sources powering life support systems and other essential functions. Water recycling and air purification systems are crucial for creating a closed-loop environment. Moreover, Martian habitats need to provide psychological comfort for their inhabitants. Incorporating natural light, simulating Earth-like day-night cycles, and creating spaces for recreation and social interaction are essential for maintaining mental well-being in the isolated Martian environment. The development of Martian architecture is not merely about creating shelters, it's about designing a new way of life. These habitats will be the cradles of Martian civilization, the foundation upon which a new society will emerge. They will be testaments to human ingenuity and adaptability, showcasing our ability to thrive in the most challenging of environments. And they will serve as stepping stones to further exploration as we venture deeper into the cosmos, carrying with us the lessons learned and the spirit of innovation honed on the red planet. The Martian atmosphere is thin, composed primarily of carbon dioxide, making it unbreathable for humans. Generating breathable air is therefore a critical challenge for Martian settlers. One approach involves extracting oxygen from the Martian atmosphere. Through a process called electrolysis, carbon dioxide can be broken down into its constituent elements, carbon and oxygen. The extracted oxygen can then be used to create breathable air within Martian habitats. Another promising avenue involves utilizing Martian water ice. If accessible in sufficient quantities, water ice can be electrolyzed to produce oxygen and hydrogen. The oxygen can be used for breathing, while the hydrogen can serve as a fuel source or be combined with nitrogen to create fertilizer for Martian agriculture. This approach hinges on the availability and accessibility of Martian water ice, a resource that continues to be explored and mapped by ongoing missions to the red planet. Beyond generating oxygen, maintaining air quality within Martian habitats requires sophisticated life support systems. These systems must remove carbon dioxide exhaled by humans, filter out dust and other contaminants, and regulate humidity levels. Advanced filtration technologies, combined with robust air circulation systems, are essential for ensuring a healthy and breathable atmosphere within the enclosed environments of Martian habitats. Creating a breathable atmosphere on Mars is not merely about providing oxygen, it's about replicating the delicate balance of Earth's atmosphere. It's about ensuring the long-term health and well-being of Martian inhabitants, allowing them to thrive in an environment that would otherwise be hostile to human life. And it's about laying the foundation for a sustainable Martian ecosystem, one that can support human life not just for years, but for generations to come. As we look toward the horizon of Mars, we invite you to imagine the possibilities. How do you see humanity shaping the red planet? Will it be a thriving hub of scientific discovery, a new home for future generations, or something else entirely? Your vision is a crucial part of this narrative. Drop your thoughts and dreams in the comments below. Together, let's build a future that reaches for the stars.